All right. Good afternoon, everyone, or good morning, good evening, good night. Welcome to the Earth Observation Australia webinar on where to next for teaching and training in remote sensing and Earth observation. My name's Stuart Phinn. I'm based at the University of Queensland, and I'll be running things for today. We do have a relatively packed schedule, so I'm going to get into it quite quickly. Just before I do that, if there are any technical issues where you can't see or hear things, please type a question into the chat and we'll try and respond there as much or as quickly as we possibly can as well. Okay, so welcome everybody. Thanks very much for your time today from wherever you're coming from all around the world. So before we start, I do want to acknowledge the traditional custodians of the lands and waters on which we're meeting and working, both here in Australia and overseas, and pay our respects to elders past and present, and acknowledge the work that we're all doing together to try and move forward in this space. So I know a lot of you are coming from different areas around Australia, so it might actually be helpful just for people to type in, in the chat window where you are in Australia or where you're coming from around the world as well. So we do have a panel today, and we're going to have essentially the first, I guess, half, 3/4 of what we're doing, talking amongst the panel and hearing questions from everybody in the audience about, I guess, a whole range of challenges that face all of us. So I'm not going to introduce everybody in detail. The bios for the panel are going to be at the end of the slide set, which you can download afterwards. I'm just going to introduce people briefly. So we've got Associate Professor Joyce from James Cook University and GMAPS. Neale from DataFarming, who are based in Toowoomba, Dr. Amy Parker, who's the Earth Observation Director at CSIRO, that's Australia's National Science and Research Organisation, Dr. Caroline Poulsen, who is a lead research scientist in the Bureau of Meteorology in Melbourne, Dan Tindall, who is the Director of the Queensland Government Remote Sensing Sciences program in Brisbane, and Professor Ian Woodhouse, who's joining us from Edinburgh today. Ian's at the University of Edinburgh, but is here in his capacity in Earthblocks, a company which he's been involved in establishing and which we're going to hear about in a minute. So a couple of things, aims and outcomes for today. So the first thing is we want to get a sense from the people across the panel and the audience is, what are, I guess, the current status and challenges that we have in terms of those people who are teaching remote sensing or Earth observation in Australia and probably elsewhere around the world. And yes, a lot of that does happen within universities, but it also happens directly within government agencies, private companies and NGOs. So we're all doing things to push forward to the teaching and learning. So we'll talk about those challenges. The second thing is look at what the gap is between, what's required in the professional areas, whether it's industry, government, non-government organisations, research, universities. What do those employers, if you want, require from graduates versus what's coming out of our universities and other things at the moment, and how do we address that gap? A quick sort of spoiler alert, we all know there's a big gap there, and how do we address it? And that's the reason for having this series as well. And what we're also going to do is hear from Ian, where he's going to introduce Earthblocks, which is a slightly different way to address one of those critical gaps that we've got across several different ways of doing remote sensing and image processing. where you can deal with quite large, complex data sets and bring people into that environment. So it'll be interesting to hear about Earth blocks later on. Okay, just some scene setting to begin with. Apologies for the colour. Teaching Earth observation or remote sensing is challenging when you look at the career areas that people end up in. There are all of those areas around that green box there, and it's everything from the build, design and operation of sensors through to the collection and processing of data and the use of it in a range of key things. There is a core set of knowledge and skills. These are obviously my biases in presenting that. And this is probably something we're going to come back to today and try and look at, well, what are those things in the middle there and how does it relate to all of those other areas and what they actually need? So this is a diverse area. It's not a nice, neatly defined area. This is an area where there's a lot more being published now than there was 5-6 years ago. This is a recent article at the beginning of the year that Morgan Crowley and colleagues published, looking at cloud-based Earth observation, online data processing. What are the key knowledge, skills, and other sort of professional capabilities that you need? And they've grouped it in terms of, fundamentals, ethical considerations, and communication and engagement, which I do think are really important and we need to. And it's, today is really about how do we move across this, traditional space into maybe a slightly different one. If we look at other fields like geospatial analysis, they also tackle this problem, and they've got core skills in the middle and everybody works around the outside. So how do we link into all of those? I don't know the answers. But again, looking at geospatial technologies, this is from Esri. These are the competencies going from sort of the bottom upwards, which you can build in a geospatial area if you're going to work in, using and producing and delivering, geospatial solutions. There's probably a similar pyramid in there for Earth observation as well. And you can see it's not just around sort of image processing algorithms. There's a whole set of other activities. Okay, let's jump into the first discussion here. So the way that we'll work with these is I'll put the question to the panel and essentially, we'll offer ideas on this and, try and keep track of things. While we're doing that and bringing up individual points, if the audience have points that you want to make, please bring them up in the chat window and we'll come back to those as well. And I should have reminded everyone at the start, we are recording all of this. So, what's on the video, what's on the audio stream, what's in the text, in the chat, whether it's private or public, is all recorded as well. And the way we run meetings is by the Code of Conduct for Earth Observation Australia. If you want to have a look at it, it's on our website. So without further ado, what do we consider are the main challenges for delivering, work-ready remote sensing people in Australia? And I'm going to angle this slightly towards educators to begin with. So what do, if you're educating people either in a university or on the job, like what are your main challenges in that area? So Karen, could I just go to you first, because you're an academic at James Cook University. What do you consider the main challenges for delivering, courses, content, whatever, to do this?
Thanks for going to me first. It's so big, and it's such a challenging question. So at James Cook Uni, we have only one remote sensing subject. It's taught to both undergraduates and postgraduates at the same time, and there's no room to put more remote sensing subjects into the degree programs or into the curriculum, or maybe not so much not enough room, but I guess not the financial backing to do that and the number of students to support it. So one of the biggest things that I find is that people take the remote sensing class and they think that they know everything because, well, there's only one class, so that must teach everything there is to know. And well, it's not even close, and I think they barely get past the stage of not knowing what they don't know. So for me, like I'm kind of hamstrung in that space. You know, there's so little more that you can do aside from know that they're going out into the workplace without that full complement of skills. They've just got a taster. So I might pass that on to the next person to start discussing that, Stuart, because I could probably take up the whole hour and a half otherwise.
No worries. Well, maybe let's switch gear a bit, and then just going to Tim, Neale and DataFarming. You run a company that employs people, and you bring them in. Like, how much do you actually have to train people when they come in? And, you know, is there that sort of gap there?
Yeah, thanks, Stuart. Yeah, there's certainly a gap, and I feel it's getting broader. I mean, you know, we've seen, you know, some fairly low standards come through, even with master's qualifications. So I think the bar keeps dropping a bit without being disrespectful. And, you know, whether that's the quality of the students coming in or the quality of the education or both, I don't know. I find that the best people we get, and we don't employ lots, but we've certainly employed a few over the years, are ones that have a natural passion, obviously, and they sort of self-learn and come in work ready because it's their life rather than they're doing a course in it. So, and I guess that's probably similar to a lot of other professions. It's exactly the same. If you're really passionate about it, you'll learn and come in with those skill sets. But, you know, what you pointed out before was 100%, right? Where we're not in the old days of downloading data anymore. It's cloud processing most of the time, and there's a lot of coding in that as well. So that the world's probably had trouble catching up. I think also one of the fundamental problems, Stuart, is that the space in Australia is such a hot and cold thing, and we can't get any consistency from government over space. You know, 1 minute we're on, next minute we're off. So that doesn't send good signals to the marketplace. If you look at the US, where it's a mainstay in their daily activities, then you've got a consistent, strong message coming out. And I think that then drives the whole community's perception around space. So I think that's half the problem, is that us as a space industry in Australia, it's hopeless. You know, it's cold again now. Like, you know, we thought we were onto something. So I think that's got a lot to play with it as well.
Well, we might open that up just a bit more across the panel. So we just heard from you know, Karen and Tim talking about sort of the university experience where it's crowded already. We can't add in courses, and there's some other constraints there, which we'll come back to in a minute. And Tim's introducing that gap, and also, you know, trying to make it visible and attractive to people as well. But I guess the questions to the rest of the panel are, you know, from the positions that you're in, you're employing people. What are there any sort of really key gaps in people coming through that you're appointing? I mean, Tim's mentioned coding, but are there any sort of key knowledge or skills gaps? You know, it might be across that whole range of competencies I showed in the earlier slides. You know, there's some key things there that you're seeing in people that come in at entry level and middle levels.
Yeah, so I can comment from the Bureau. So at the Bureau, you know, Earth observation is really essential to our services. So we have about 200 people whose roles rely on Earth observation data, probably at least. We actually do a lot of our training in-house because it's not being provided by the universities. So, you know, for example, this year we accepted 50 graduates onto our graduate training program. That's a 9-month course. Remote sensing skills are a major part of that remote sensing training course. And for that course, we're primarily looking for people who have a maths and physics background. If they have some remote sensing knowledge, that's extra, that's really great. And I think these skills are really in demand by many organisations. So we're competing for the best talent, offering a public service salary. And the other key aspect, I think, is that there's a lack of awareness, I think, of the importance of Earth observation to our field, meteorology, but to other fields in general.
Thanks, Caroline. Does anyone want to add on to that on the panel as well, in terms of, I think, Amy and Dan, in terms of your organisations, you're both employing people in these areas. Are there similar gaps, like it's hard to find people because they're in demand and the other positions that they're applying for pay more?
I'd say picking up on some of Caroline's really great points there, that you're looking for the kind of the core fundamentals and the potential to be able to develop into kind of a successful employee. So particularly, we've been trying to find people who have significant experience with synthetic aperture radar, which is pretty difficult in Australia, or people are very much focused on a specific application. So for example, a geophysical application looking at measuring ground movement rather than, say, using SAR to look at changes in vegetation structure. But if there's that kind of, they're able to demonstrate that core, the core capability, the core understanding of the technology, then there's obviously potential there to transfer it into a slightly different discipline. And I really think that the point that's raised about coding is absolutely key. I came from a geophysics background, so coding was really embedded into everything that we did during that degree course, not just the one remote sensing module that was done, but really having a strong basis, particularly I think increasingly in Python, and I've seen that popping up in the chat a few times. So I would really emphasize the importance of Python, and then also, of course, we look for the other things, the demonstration of the passion of students who are looking to do something more than just have good grades. Are they trying to run seminars for the department? Are they on councils? Are they getting involved in different organizations? The demonstration of that passion is a really strong when we're reviewing CVs.
Thanks, Amy. Dan, do you want to add into that as well?
Yeah, thanks, Stuart, and Amy and Caroline particularly for sort of laying the government foundation there, because it's really similar for us too. I think your first slide summed it up, Stuart. You've got that suite of core capabilities, but you've also got this broad sort of spectrum of things, be it environmental science, ecology, geography, maths, physics, even biochemistry, these sorts of things that all play out in remote sensing. And for us, in some respects, we almost ask too much of candidates, because we're sort of looking for this happy medium of all of those things, as well as coding skills, etc., when they come in. You also made a really good point earlier that universities, schools aren't the only educators, and as Caroline said, we have a major role to play as educators. We can't expect people who've done a 4-year degree to hit the ground running in the kinds of high-level tech and all the applied areas that we've got to function in as well. We've got to also take this stuff to policy people, explain it, deliver it, put it out in the public domain. So there's a wide range there of things. I guess the glass half full view of that is it does sort of, particularly in our area, I guess it be the same for CSIRO, the bomb. What it says is remote sensing is a career path that is wide ranging, and you can come from various vocations or areas in study into remote sensing and be really successful and have a really interesting and challenging career. And I guess, it was interesting, Karen's earlier comments, I actually did a very quick Google this morning on undergraduate dedicated remote sensing degrees. The only one I could find was in Islamabad in Pakistan. So, you know, that's something that we've got strategies, chief scientists, etc., all saying we've got to move into these emergent technologies, emerging industries, emerging areas, and EO and remote sensing are very much a part of that. Yet we're not yet influencing our education system to be geared up for that in the right way. And I mean that from a government perspective as much as from the academic sector. Interestingly, chief scientist said 72% of parents would encourage their child to consider a science-based career in Queensland. You know, we've probably got a task there, and this probably goes into the second point, but you know, we've got to tap into these people before they're going into university, make them sort of follow those paths that, so there might not necessarily be an undergraduate degree dedicated, but we can steer them into the right areas so that they're coming out with those skill sets that we need and that passion and knowledge that this career and this industry exists. And I think that's, you know, I had a really good experience at a high school recently where I spoke to 15 kids in their lunchtime, and one of them came up to me at the end and said, "That was awesome. I really, really interested." And to me, if you can get 1 out of 15 kids interested in Earth observation, you've had a win.
Well, thanks, Dan. Just being mindful of time and trying to balance some of these things out. That's covered a whole, I think, range of points there. And I just want to summarize a few key things before we move on to the next part and questions. And again, thanks everybody for the, I guess, the points which you've made in the chat window. If, you know, there's actually questions there as well, can you put those in and we'll come back to them. So I think listening to what people have just said, one of the key things that I think is starting to come out is that there is that need for more partnerships between, I guess, our education institutions and, you know, the government agencies at particularly the state and Commonwealth levels, as well as partnerships with private industries. Now, a lot of our professional degrees have these things built in, and I think it's something that we could potentially push in terms of making what's happening here more visible in universities and enabling students to build that solid base in, you know, the relevant sciences and other areas, so they are capable of coming in and knowing they're going to learn on the job and do other things as well. I think that's really important. I think from an Australian context, you know, our universities are going to be squeezed in the next 2 years even more from a financial point of view. So that there are challenges in adding things in, but if we're able to link what we're doing and refine it more effectively, I think that's something that's, you know, we would get support to do internally, and it would lead into that. And this is something that might be a follow-on webinar here, where we do have companies and governments that have these programs where we can explain them and, you know, how do we get it out to students? Students are making much more value-driven choices in what they study now. It's not necessarily what career, it's like, how can we work in an area where we do this or change something? And that's been a big shift. So, all right, what we might do is just shift gears a little bit. I just had a quick look through the chat, and I can't identify any specific questions, so I'm going to keep going, and we are a little bit over time. But if there are questions, please type them into the chat. There's a lot of really helpful comments about what people's experiences are with software, and, you know, that going between traditional, you know, pull down graphic user interface, code driven environments as well. We'll come back to those questions in a minute. Let's just go to the second part of the panel discussion, and that's like, you know, is there a gap between industry requirements for Earth observation professionals and what the universities would describe as work-ready graduates. And if there's not, let's dig into this further. You know, how do we actually address that gap? We started to talk about that in some of the responses that we just had. So these partnership programs, or from the university point of view, like from my university's point of view, that would be a placement program where essentially students get credit for it, and they also work out getting paid for things as well. So that's maybe one way of doing it. But I mean, are there other more effective ways of addressing that gap in terms of how we go forward? I might just start with Caroline again. So Karen, you're off the hook the second time. So what are your thoughts on that, Caroline? And then let's open it up a bit broader.
Yeah, so yeah, really interesting, and I really like some of the previous comments about trying, getting that passion for the subject. So at the Bureau, we really recognise that we haven't got a very strong pipeline of people with the right skills coming into the Bureau. I worked in the UK, and there was a much stronger pipeline of graduates working in the field of meteorological remote sensing, which was supporting the UK Bureau of Meteorology quite strongly. We don't have that here. So I guess the Bureau is really keen to start developing some of those partnerships with universities through having interns, through having at undergraduate level, summer students, PhD students, joint projects. I think that's a really effective way for the Bureau to, get the right talent.
Thanks, Caroline. And that you did mention summer and winter programs. I think some of us know about that, but just for everybody else, universities will actually support or pay students for a set number of weeks to work on fixed summer and winter semester projects when there's not classes running in that sense. So that's actually something where, again, if we could link things up, it would be good as well. Any other thoughts on the potential linkages and how we could start to address that? I don't know. I mean, Tim and Amy, in terms of the more sort of industry and research area, there are some ways that you found helpful there.
It's a bit like everything, mate. I'm looking at this from a business point of view almost, where if it's demand driven, then you're going to get someone to fill the gap. And what I mean by that is we've got to create a demand that's big enough to get everyone excited about it. And that means getting businesses and government to actually have the demand on the services to deliver. And we see a lot of technology in this space head straight over to the US. People get a bright idea, they don't get much support, and they fly straight into San Francisco. And I think that's an absolute, that's one of the biggest shames of this country, is still not supporting people to do that. So what that leads to is, if you have homegrown businesses, and me in Toowoomba, it's really hard to get people, right? Like, it's bloody impossible. I mean, I'm lucky to have 3 really good staff here in data science and spatial science. But if I have big demands on me for more services, then I need more graduates, and then it'll flow down the line. But unless it's support, unless we can drive the demand across the mining, energy, environmental, agricultural sectors in this space, that's where it's got to come from. It's got to come from business, right, or government, to employ these people. And government's not going to go out and employ thousands more EO people, but business will. So it's got to come demand driven. You'll fill the gaps. If there's 50,000 people sign up tomorrow to be EO scientists, you're going to fill the gap in the university, aren't you? Because there's money in it. So you will work out a way. But I don't think that the country's not driven like that at the moment. And I think that's the point about the UK that you just mentioned, Caroline, probably because there's a demand-driven thing there, right? So it's got to work from that end first. And what we need, just following on from the sort of skill sets, it's some really good points just before. We don't need everyone to know everything, but we've got specialist people in each area that, like, we've just put another 3 people on recently, and they all operate in little bits of different areas of this whole piece that is EO and software development. So but you need to have skill sets and obviously the base science and some base coding and things like that. Otherwise, you're not going to survive. But we get specialists in each part of that to work together rather than everyone trying to do everything. One interesting point, I mean, in the chat, it's been good to see even GEE mentioned, Google Earth Engine mentioned. We've been using it for a long time, and every single graduate I've ever talked to has never, ever used GEE. So we have to train them in-house or they'll learn themselves. You would have thought that we would have seen that kind of skill set at least, coming out of the unis, but we haven't. So there's still a lot of gaps in basic stuff like that. Anyway, that's probably enough for me, but there's a lot in there to unpack. But, I think it would sort itself out if we had enough demand.
Yeah. Thanks, Tim. So there's some points about demand, and then also there's a mismatch between what the industry and application areas are using and what's being taught, and that's the thing that we need to get out there. Like if we take that a little bit further and go, okay, how do you actually build a group of people, who are going to deliver these skills and do it in a way that's viable in the longer term? I think for whether it's universities or other groups that are doing it, it's like, how do we actually communicate something like, well, here's the need. So maybe there is a need, for a national organisation to say, here's what's there, here's what's accessible. A number of us, and there's been comments in the chat, are using Digital Earth Australia's, I guess, online capability and their sandbox training capability, which tends to work quite well, and it's similar concepts to what you're going to apply in Earth Engine as well. But it's challenging to make that transition. So I guess in terms of larger national programs, and this is where I just want to go to Amy on. I mean, your role with CSIRO as a national sort of research organisation. I mean, is there, in terms of, I guess it covers space, but it also covers all the different areas that use remote sensing, whether it's dealing with sort of ecological sciences, the sort of, atmospheric sciences, oceanographic sciences, energy resources. What sort of role do you see CSIRO and other national organisations playing in defining here's what's needed for an education?
A good question, Stuart, and not wanting to speak on behalf of the whole organisation, partly given that it's so large and EO is used across so many different domains. So if we look at the way that CSIRO now presents the science that we do to address kind of key grand challenges for Australia and the world, if you look at those, EO actually directly applies to 5 out of 6 of them. It's a hugely important data source for so many different scientific disciplines, as we all know. And I think we really see kind of 2 models of people coming in. So there's people who've specifically studied spatial science or sort of GIS and have really focused on remote sensing throughout. And then there are those who have studied a specific discipline, whether that's geophysics or ecology, and remote sensing has been part of their toolkit. And perhaps in an honours project or in postgraduate education, they've really honed in on the type of remote sensing that they're using and really develop those in-depth skills, all of the coding skills, etc., that comes with it. So there's sort of those 2 different models of people coming through. So I suppose it's being able to communicate that need at the kind of general, we need people who can do EO and spatial science, versus the kind of model where we are using it as part of a toolkit to be able to meet that science goal. And I think there's kind of slightly different communication needed in both of those different models. So the things that we do to try and bridge this gap and to start that initial early training is, you know, the summer vacation students that we have for sort of 12 weeks over the summer. We also have kind of PhD top-up scholarships where we're trying to really define a specific need that we identify. And, you know, I'll just put a plug out there. We've got one for bushfires in SAR at the moment. So if you've got PhD students studying that, please get them to apply. And then, you know, postdocs and other opportunities. But really, you know, it's very much focused on individuals, and it's not really getting to the large scale problem. So I think through forums like this and sort of working together around that communication piece and highlighting that the demand is there, and perhaps it's just not coming across clearly enough to students, and the potential of what they can do, the breadth of what they can do, you know, the fact that there are so many exciting opportunities around Earth observation perhaps isn't really that obvious to students and graduates at the moment.
Thanks, Amy. So I want to segue from that into a point that Karen's made in the chat, and also use that to, I think, put it a bit more in context. I think, as a lot of the panel members have said, you know, students going into tertiary education or vocational education, there's such a big choice, and it's not clear what to do. A lot more people are coming into that space going, I want to work on this problem and solve it, like food production and things like that. Karen's raised a point there that says it's more important to teach people how to be creative and problem solving than, you know, using a piece of software. So Karen, I might get you to just come back on if you can and comment on how do you balance that with having, you know, the core sort of knowledge and technical skills, as well as having that problem solving and communication. And again, just a point there, I mean, this is something I discourage students from talking about, which is like, oh, I do hard science or soft science and that, and that just does my head in, because all of those things need to work together to actually understand and solve problems. But I'll stop that rant and go back to Karen. So what do you think about combining those two areas? Like, how do you do it?
Yeah, I think it's a really interesting one, and I'll speak both from the tertiary perspective, but also at the primary and secondary level as well. To start with, at the tertiary level, I feel that students that come to me at JCU already have it ingrained in them that they need to know the right answer. They need to learn something generally by rote so that they know what's going to be on the assessment and how they can get the right answer to be graded in a particular way. And it's actually quite difficult to break that mold for them and try to get them to learn that actually that's not what a good learning outcome is. And the exploration and the feeling that you need to throw the computer out the window because you're trying to work through problem solving, and that whole process is the learning outcome itself. And I think that the frustration that students feel when you're trying to take them down a different learning journey in that space is brought on through a lifelong learning process in institutions that teaches students a certain way. I'll go back to specific examples that I see in primary school and high school, and particularly around the coding side of things. So I run a program where we teach kids geospatial science through using drones, and that has a coding component in it, which is coding by block coding, which I guess is what Ian's going to show a little bit later, but in a much simpler way. And when I go to schools, and particularly schools that tell me, oh yeah, our kids are amazing at coding, they've been doing Python since grade 3 or whatever it is, because they actually do bring it in the curriculum quite early. They're awesome. Yep, they'll have no problems with this. But when you present them with a challenge where they have to problem solve to understand why they might code in the first place, and then what that code might be, they can't do it. So if you tell them, oh, I need the drone to do this, this, and this, they can code for that to happen, but they can't solve the problem in the first place. So it's, again, just breaking the system. that teaches by rote, and it teaches, yes, you've got to push things through in a curriculum so you can tick boxes and get out the door, that then actually gets forgotten about later because they haven't learned the full problem solving and creativity process that allows you to fail along the way. So I don't totally have an answer to it. I feel like it's actually a lot more fun to teach students to fail, but it makes them really, really uncomfortable as well.
Thanks, Karen. That's actually a good sort of switch point for the moment, and it's going to lead into, I guess, what I hope will be some future webinars in this area of how we tackle this in both sort of the university setting, but in sort of the high school, primary education and vocational education, as well as our workplaces, and how do we actually approach that? It's not simple, but we've got the bits and pieces here to start doing that and working out how to address it. I mean, I'm looking at the people who are on the call. We have people who are heads of departments. We have people running companies. We have people who've been in the field for a long time. We have like our textbook authors on here as well. We actually do have that ecosystem to put things together and make things work. All right. I'm going to draw the line on the discussion here so that we can get properly into Ian's presentation with earth blocks. I really do want to thank everyone for the comments in the chat window, which we'll make available after the presentation along with the recording as well, because there's a lot of really useful points coming up in that I do think we need to come back to later on. So thanks very much to our panel members, and we'll come back briefly at the end. But what I'm going to do now is just stop sharing and essentially introduce Professor Ian Woodhouse from Earth Blocks today, or the University of Edinburgh, who's going to talk to us about Earth Blocks. Hopefully some of you have come across Ian's work already in Imaging Radar. I would also really commend his article on abandoning ground truth, but that's another story for you to have a look at. Ian, over to you.
Great, thank you, Stuart. And good morning from Edinburgh. Hopefully that's showing as a full screen presentation.
All good.
Right, so brilliant. So I'm going to talk a little bit about earth blocks, which fits in fantastically to the discussion that we've just been having. And I've got a couple of slides, and then I'm going to go into the product itself and give you a couple of demos. There's no time to get into absolutely everything, but there's my contact details are there if you want to drop me an email, if you want to get a bit more into the depth and explore it a little bit more. Now, a few people in the chat were mentioning Earth Engine, and I'll be honest with you. And the origin of Earth blocks is essentially I was too lazy to learn JavaScript. I thought I'm too, you can't teach an old dog new tricks. I've done my Fortran in my past, so I know how to code. But I really wanted to get into Earth Engine, and I can't. There's too many semicolons and everything else for me to get my head around. So we initially built a very simple prototype of a visual programming interface to Earth Engine, essentially to satisfy my needs of being able to get right into. In fact, it was interesting that Amy talked about the science goals, so that I could get into the science goals without actually worrying too much about the actual components of the coding. And since then, that was back in 2008, beginning 2019. And since then, Geneviève Patenaude, who was my colleague at the University of Edinburgh, she took it on as a business idea and has built Earth blocks from scratch, from that very simple prototype into an actual commercial product now. Just a quick background to who we are. So this is part of the core team. This is the Earth observation sort of team. So there's myself. I've got about 30 years of experience looking at synthetic aperture radar, mostly for vegetation primarily. Geneviève comes very much from the background of remote sensing as well, but in a carbon context. She's also one of the contributing authors to previous IPCC report. Very passionate about how businesses have to tackle climate change as well. So she's keen to make sure that the industry and business at large are part of the solution rather than just being a problem. Some of you might have heard of Mike Levsky, who was at Colorado State University. So he's been our input in terms of some of the data layers, and specifically on the LiDAR side. Tim Newman comes from the Ordnance Survey and has built online products for them. And we're very much a purpose-driven company. We want to make our contribution to tackling climate change by making it much easier for people to tap into big data, satellite data in particular, and bringing that into this whole picture of sustainability reporting that's a big driver at the moment. Now, in terms of following up on the panel discussion, one of the things that I have seen, I believe in my career, is a divergence now to two very significant groupings in the Earth observation and remote sensing context. One is what I call the builders, so people that are building solutions, and they need to be able to code, and they need to understand exactly the technical components underlying remote sensing. But there's an increasing group of people who are applying solutions. So you've got builders and you've got applications people. And the applications people tend to be domain experts. They're less proficient in coding. They don't come from a technical context, but it's the domain experts that we kind of see as our key focus area for Earth blocks. We want people, I love Karen's point about being creative and problem solving. So how do you get people accessing the data, domain experts being able to get into the data really quickly and do stuff? And my analogy, I'm going to give you a simple analogy very quickly. How do we get people to their solution quickly? How do we get them from A to B as fast as possible? Now, my little analogy is, in terms of just distance and getting from geographically A to B, is that one way is you can get a taxi. So this is more relevant, I guess, in the commercial world rather than in the educational context. So my analogy here is that these are the consultants. Okay, so they tend to be more expensive. It's an expensive way to get from A to B. You tend not to have much control over which route they take. You might have a little bit of control over whether or not they're an environmentally friendly taxi company or not. And you've got to trust the driver of that taxi to get you to the place that you want to go in the right timeframes. You can always drive yourself, but driving, especially if it's a manual car, it requires quite a degree of expertise. You got to get trained and licensed in it. There's lots of buttons and dashboards in order to get yourself, if you're driving, from A to B. And that's the analogy of those technical experts, the people that are doing the coding. So all the chat just now about how important coding is. Well, if you want to drive the car yourself and get from A to B and have full control, possibly also know a bit of engineering and know how to fix, a flat tire or when the engine goes wrong. It's important, and EarthBlocks is not trying to replicate or replace that component of Earth observation. We're more, I guess, in the self-driving car mode, whereby the driver has, or the passenger now has full control over where you're going to go and how to get there, but you're generally just pressing a button and you're trusting the engineering and the scientific input and the technical input into the self-driving car that will actually respond to your needs and get you to where you want to be. And so that's where we kind of see where we are. And the focused, it's these scientific goals. Okay, so the main outputs that you're going to get from Earth blocks are maps and stats, so tables and graphs and charts. We're also just about to launch our API. So in fact, you will be able to get Earth blocks answers straight into spreadsheets and things through APIs, for example. So that's the newest addition that's going to be on there. One of the key things that we're trying to help with is the selection of data. So not just the data catalog, but also finding a way to make it easier for users to know which data is the appropriate one to use. And I'll show you that in the actual demo. And then just this little quick animation to get you into the mindset of the key interface component of EarthBlocks, which is a visual programming interface. So you basically drag and drop the various components and the instructions that you want to do to the data. And that's how you get essentially what is Earth Engine in the background originally, but we've now augmented that and added to it. So there's other data sets and things that we can now use. And as people are aware in the chat, you know, the value of Earth Engine and the cloud-based processing is the fact that you can get to a huge range of different data sets very quickly. You can scale it up. So this is Cambodia. So this is looking at risks from flood and drought and wind. So things like the drought map there is how many drought years there have been in the last 20 years in Cambodia. So it's being able to access this vast resource of data without having to go through those steps of downloading a tile, stitching it together, doing all the individual analysis on your desktop. A quick one, I threw this in for Karen because I think the last time you saw Earthblocks, we couldn't upload our own geotiffs. So we can now do some LiDAR analysis. This is me just trying to look at solar potential in an area in Scotland based on LiDAR data. So you can upload your own data and use that as well as the data that's available inside the platform. And we now have a range of people, so it's not just universities. Universities are using it in a teaching context. So the value I see in the University of Edinburgh is that we can get people across a range of different topics. So that who was, I think it was Stefan talking about the multidisciplinarity. So it's in that zone of the application solutions people, is that we're teaching our master's program that is teaching about or training up the builders, but we're also trying to get the applications people, those domain experts, very quickly and with a very short runway to get them onto looking at Earth observation data very quickly. It's what the MIT people talk about of having a low floor and a high ceiling. So that the low floor means that people can get in really quickly. The high ceiling means that you can actually do quite advanced things once you get into it. And the wide walls means that you can apply it to lots of different contexts. So let me go into the actual platform itself. So hopefully you can see that it's a map interface on the right-hand side. On the left-hand side, it's our toolbox. What we do to make it as easy as possible for people just starting off is that we actually have a whole range of template projects. So these are much more focused on a specific task. So that science goal question or a practical goal. And one of the ones I'll show you later, for example, is this one is a fire risk one, but I'll come back to that in a second. And so you can upload your own assets, which means vector files as well as geotiffs. And we can now also export as geotiffs as well. So if you want to go from Earthblocks and then take students on a path that takes them onto something, some other piece of software, a lot of people mentioning Envy or ENVI on the chat there, is that you can do some of the early stuff on Earthblocks, and then you can export geotiffs, take that to QGIS or ENVI. So the idea I'm going to talk you through, well, I'll give you quickly the interface. One of the key things we also have is we've now built quite a large help center. So, and we're trying to build that, the help articles from assuming that people are coming from a fairly early basic understanding. So we're giving them a foot up in terms of being able to do some of the remote sensing science. But I'll quickly show you the interface. The idea is that you have these blocks. Your toolbox gives you a whole range of different blocks that you can interact with in terms of calculations and classification, as well as the displaying it then on the output over here. Our catalog, so we don't have all of the Earth observation, the Earth Engine data catalog isn't fully in here yet. It's we've got about 45 data layers which have been chosen primarily on their how often they're used and the significance, but it's pretty easy for us to take on any data set that's already in Earth Engine. We can get that within a couple of days. That can be loaded up into the platform. The other thing we can do now is that if you've got data that you've got commercial access to, individual users or particular client companies, you can, or organizations like university, if you've got access to a particular data set, you can load that you can have that loaded into Earthblocks and get access to it through the platform. just to quickly show you the information that we provide for each of the data sets. We make it easy to get where the data comes from. So we want to be very transparent about where the sources of the data are. So you get links to if it's on the Earth Engine catalog, or if there's the Nature paper here this is for the dynamic world, and also the terms of use, which is more relevant for the commercial organizations that might be using the data. So you click that, and it automatically generates a set of blocks that are appropriate for the data that you choose. It will define the visualization options by default that we consider to be the most appropriate ones for the data that you're using. If I just have an example here where we might take add a quick area. You can click run on the individual block, and what that's doing is essentially, in this case, it's getting the Allen Coral Atlas data for that area you've chosen. You'll notice that it automatically updates the drop-down menu. So when you add areas, it automatically populates the drop-down areas on the block so that it makes it much faster. There's very little typing in. It's mostly through the drop-down interface. And that's the data, visually displayed. But what else can you do? So very quickly to finish off, because I appreciate that we're running over the time. That was a quick example of other data that you can pull in. So it was one of the example data for the methane carbon mapper online data that I uploaded myself and then mapped onto here. So this is a plume of methane that's coming out of this location here. And the final thing I'll show you is this is a bit of an example of the high ceiling. So this is a bit more of an elaborate set of blocks. They're all color-coded to make it easier to follow. They have various things like tooltips and things that help users see what each of the blocks does. But I wanted to show this to also not just to show the output. So this is the fire. I think this is Darwin up here in the north. This is the occurrence of fire over a period of time from 2019 to 2022. And we also get, in this case, the dashboard output. So we can generate the dashboard output and an interactive chart that you can change the parameters of before you export it. So you can get real numbers out and export them as CSV or PNG files for adding into reports and assessments. Right, I'm going to finish there. That's me done.
Awesome.
So the other quick thing I'll put in the chat is I also did a set of very short videos. We did a set of videos that were for absolute beginners. So if you're trying to bring in somebody into Earth observation that has absolutely no background in satellite data, these little sets of videos, it essentially exploits the fact that there's a 14-day free trial for the individual user licenses. So it's got 14 little videos that are only 5 minutes each that takes people through those days so that you can get people signed up to that if you want.
Excellent. Thanks very much, Ian. There were a few questions, but I think what I'll suggest is that people get in touch with Ian afterwards about those in terms of following up. Just conscious of time and trying to wrap things up for today and then to lead on to the next parts. I do want to thank our panel members and especially, I think, Karen and Ian, who are calling in from quite different time zones. And as we said in sort of the advertising for this is one of a series which we're hoping to continue, where we can come back and talk collectively about how to solve a number of these problems, which is, I think, the point it got to in the chat there. I think it's also really important, that groups like EarthBlocks get exposure so that we're aware of them and can start to engage with those and bring all the different components in Earth observation together. Because yes, on one hand, we need some lower entry points to get in, and then people can get in and deal with the higher end science side of it and put it all together. So just recapping in terms of what we've covered today. So those 2 points we talked about briefly in our panel discussion. I did look at, okay, what are we actually doing in terms of teaching in this area? very briefly. What are the gaps that we're seeing between what's coming out of our educational institutions and what's being employed? We probably didn't talk as much about what the limitations are in terms of delivering these sorts of courses, but it was probably good because we can focus on what solutions are with what we have at the moment. And then Ian's excellent presentation gave us an example of, how do we reduce barriers of entry to getting people in? And that analogy of sort of the low floor and the high ceiling is a good one, because there's a large expanded capability there if you know what you're doing in that space. And I do want to finish off just with a point there in terms of online resources. So Earth Observation Australia, through all of Barbara Harrison's hard work, and I think Barbara's online at the moment, we do have an online series of textbooks which build into this area quite nicely. And there's the link there if you want to have a look at them. So just to finish off with for today, and again, thanks everybody for joining. Couple of things. Our next webinar will be in October, looking at groundwater status from space. So that's something we don't normally hear about. Earth Observation Australia will have a new management committee in October, so more exciting stuff. The forum, which we had this time last year, is going to be back on in 2024 in Adelaide. And there is an exit survey for today, which I think is in the chat window, or Larissa, is that right?
Yes, the link's in the chat.
Okay, so the link will be in the chat for that exit survey. I'll get Larissa to put it in there. So again, thanks everybody for your time today and listening and contributing. It's the first step in hopefully a couple of other activities. And we do want to hear from you in terms of what worked, what didn't. We know everybody doesn't have much time, which is why we've tried to bring it together. So thanks again, everybody, and especially big thanks to Ian and Karen as well for joining us as well. Cool. Thanks, everyone. See you later.